Experiment 2 is about simple and fractional distillation and gas chromatography. The objectives of the experiment are to separate pure liquid components from a mixture and to analyze the components using gas chromatography or GC. This is the micro kit. Alright, so I have all the glassware in here that I need for the microscale distillation. So I will use what is called a round bottom flask. This is RBF. Okay, I already put boiling chips. So the boiling chips coming from here. Okay, so I put 3 boiling chips, and then I'm gonna use also what is called a adapter. So this is an adapter from the kit, and then I will also be using what is called a distillation head. This is a distillation head, and then another adapter for the thermometer. Okay, and I'm going to be using a thermometer because we're going to measure the temperature. So the thermometer, when you use a thermometer, make sure that for this case we are actually using this thermometer. It goes up to 110. Okay, and make sure that the blue liquid inside is not broken, otherwise your readings are gonna be off. So that's the first thing that you have to inspect whenever you're using a thermometer. So this is the bulb here at the bottom. So this is the bottom, and the top one is this one. So never invert it, okay? So room temperature right now is around 24. Okay. Okay, so the thermometer at the bottom, make sure the bulb, the bottom, the lower part, and then the top one. So again, make sure that this blue liquid inside is not broken, and it's measuring correctly, at least for now, the room temperature. So I took out the RBF from the micro kit. So this is a long neck round bottom flask, and then I'm going to put the adapter. So it should snap right there on top. So this connects this glass to the next piece. So the next piece is going to be a distillation head, so it should snap on top. Okay, so slowly snap it, and it should be straight. So as you can see, this is the distillation head, and then connected with an adapter, and then my RBF, my round bottom flask with the boiling chip. Okay, so then I'm gonna take the other piece, the other adapter. It's rubber. So the white thing or the beige color, the adapter is rubber. Okay, so this thing here is rubber, while these are glass pieces. So this thing, another rubber. So this connects to the thermometer. So the thermometer, okay, so I'm gonna put it this way. All right, but I will insert first the thermometer into the adapter. And because this is glass and this is rubber, sometimes because it's dry, there's going to be some restriction, so you have to push it slowly so you don't break the glass and you don't break it and then you hurt yourself. So again, I'm wearing gloves, so you're gonna twist it slowly. Okay, and again, this is the lower end in here, that's the bulb. Okay, so now I push it, and then I'm gonna take that piece that I was assembling. So I should put it here, and because the bulb, okay, the lower portion of my thermometer should be just slightly below this curved portion of my distillation head. So it's a little bit low, so I'm gonna push it a little bit higher. And then I should snap it back in there. Okay, so slowly. All right, I slowly snap it. Okay, so probably heard that sound. So now it looks like this. Okay, so it's in place, and I'm gonna push it a little bit more higher this bulb so that it's just right below the distillation head. Okay, so this distillation head, so this is my RBF, this is my distillation head. So actually I connected two pieces from the micro kit, connected with a rubber in here, but I have the thermometer. Thermometer is not in the micro kit. Okay, so this is my setup, and I did not put yet the liquid that we're gonna be using. Okay, so that's what it looks like, and actually I can hold the thermometer and it stays. It should not fall. Okay, so I can also hold it here. All right, so that's what it should look like. Okay, this is the long neck RBF distillation head and thermometer. So I'm now going to start putting the sample in here, but because I want to put the sample, I will take this out, so I will unsnap it, okay, slowly, and then I will put the sample, which in this case, the one that we're gonna be distilling is a mixture of ethanol and 1 propanol, 1:1. Again, the mixture is ethanol and 1 propanol or N-propanol, 1:1, 50-50 mixture. So it's already made up, and then I'm going to put it into the RBF, round bottom flask, 5 ml. And because this is a pipette, it's actually calibrated to about a ml. So up to here, there's a line up to here, it's actually 1 ml. So I'm gonna pipette, withdraw a sample, 1 ml. So I'm gonna withdraw 5 times, that becomes 5 ml. So the first sample, or the first mixture, is gonna be 5 ml of 1:1 mixture of ethanol and propanol. So the one that I will now set up is actually in the figure in the handout. So this is the simple distillation. The procedure, okay, this is the figure that I'm following. It's micro scale, and the procedure that I'm following is now part A. So actually in the 3rd page over here. Okay, that's what I'm gonna set up now. So again, I took apart the setup. Just want to show you how it would look like. So now this is the RBF. I'm going to put 5 ml of the sample. So again, this is the sample, and I'm going to pipette 5 ml. So again, because it's volatile, I'm going to pipette up and down so that I'm saturating the bulb of the pipette so it doesn't squirt all over me. Okay, so a few times. Okay, that's the technique. And again, because this is 1 ml up to this part of this stem, okay, then I'm gonna measure 5 times of these. All right, so 1, 2, 3, 4, and then 5. Okay, so that's my sample. So this is the RBF, okay, that I'm holding with the sample and with the boiling chips. And then I'm gonna snap this back in slowly. Okay, that's my setup now. Okay, so now I'm going to clamp it. So I now have, okay, so I have ready already in here. So this is the setup. So I have a sand bath, right? And then I'm going to clamp it. So we have a micro clamp. I also have a jack. I have a jack in here just in case I need to raise it or lower it down. And now I have a sand bath. Okay, so this is we call it a well, and then I have a sand in here. So it's like the sand in Lake Michigan. Okay. Okay, so now I'm going to clamp it. Okay, and now I'm ready. So remember that we are going to collect fractions. We're only going to collect the first fraction, first 3 to 4 drops at the beginning of the distillation, and then the last few drops at the end of the distillation. Okay, so I labeled one vial as S1, the first fraction, and then S2 being the last fraction for simple distillation. So that's the vial. So the sand bath will heat up our setup, and then it's plugged to what is called a transformer. So I'm gonna set it to 120 on, and then this goes to the power outlet. So you can see over here, power outlet. Okay, and then I will set these to 50. Okay, so 50 around here, I'm gonna set it to 50 at the beginning. That's our setting for the transformer. And when you are using this setup for the a sand bath, don't plug this directly to the outlet because it will heat up and will destroy your sand bath, and you cannot control the heat. So this transformer controls the heating that you're putting into the sand bath. Okay, so exactly the same thing. This sand will get very hot. The same thing when you go to the beach, it's very hot, and you're barefooted, then it's very hot. So this gets very hot. This is now the sample in the sand bath, and then I started the heating, and you can see the boiling chips, and then I have the distillation head, and I also have the vial labeled as S1. And right now, because it's not hot yet, okay, the temperature is basically just room temperature, which is around 24. So temperature right now is 24 degrees C. So this is the setup. It's starting to go up in temperature. It's around 30 right now, and I'm going to put a shield so that the heat is contained using an aluminum foil. So I will have aluminum foil shielding my setup, like so, and also the top. So as you can see, it's actually starting to evaporate. So you see the liquid going up, touching the bulb, and you now can see that the temperature is starting to go up. So right now it's around 35. All right, and you can see that again the liquid is starting to condense here. It's sweating. It's like sweat on the side. All right, so you can see the distillate coming up, and then it's now going to the side arm, which is the distillation head, and this is like a condenser, and the air cools it, so the vapor is now going back to a liquid state. So you can see that it's actually going down the distillation head and it will collect in the vial. So you see the first drops coming out here. So I saw the first drop already, and the temperature right now is about 77. Okay, so we're gonna collect 2 or 3 drops. So see the second drop. So one more drop, and then I will remove the vial, and I will put the receiver, which I will collect the middle of the distillation. I don't really need to. So that's the third drop. Okay, and then the temperature right now is about, I would say 77, 78. So the temperature right now is about 82, and again, this is the simple distillation, and you can still see the distillate coming out. And then let's see if we can catch a drop here. So I'm collecting the distillate over here. Okay, so see the drop coming up. Okay, So I'm collecting, I'm recording the temperature about every 3 drops. Okay, so temperature is about 80, 82, 83. All right. So you can see that the solution is actually boiling right now, and then the temperature is about 85. So about 85, and it's still distilling. So we collected almost 3 mils already. So I'm gonna let it collect another 1 mil, and so after maybe, if it's about 0.5 mil that is left in the reaction flask, in the round bottom flask, I'm going to collect the last fraction, which is gonna be S2. So okay, the temperature right now is around 88, below 90, and the starting solution is now going down. It's almost maybe about 0.5 mil left, and then I'm now collecting the last few drops towards the end of distillation, of simple distillation. So I saw a drop came out, and then we're gonna collect maybe 2 more drops, about 2 more drops, and then we should be done with this first part. So that's another drop, and then 1 more drop. I see it coming out here, so you can see. Okay, so I saw that drop. So now so I'm now going to take out the sample, and then we're done with this. Okay, all right. So now I remove the aluminum foil, and I put down the jack lower. So I'm gonna take out the sample. I'm holding it here because it's hot if you hold this one here. So the sample that I collected, the last few drops are already in here, and then we're gonna analyze it by GC, and this is basically the leftover. So we're done with the first part, which is the simple distillation. I have the short neck round bottom flask, and I also put boiling chips, and then I took out what is called a fractionating column in the micro kit, both ends open, short, and then I will put a steel wool. So this is a steel wool, and I'm gonna push it inside. Okay, so I'm gonna push it with a boiling stick. Okay, all right. So that acts like what is called a fractionating column. Okay, so then I will use again this adapter, rubber adapter. All right, attach. I will connect the 2 pieces together using an adapter, so it snaps, and then I will attach this fractionating column. Okay, so again it's a glass, and I put the steel wool inside, and then I will again attach this in here on top. Okay, that's gonna be our setup. All right, so it will look like this. All right, again thermometer on top. So in fact, that was figure 2 actually in the handout, which is this figure 2, microscale fractional distillation. Okay, And now I'm going to put the sample again in the RBF. Okay. So this is the sample now. I put 6 ml of the ethanol 1 propanol mixture 1:1 in here. So I put 6 ml, a little bit more, and then I'm gonna assemble. So I snap back that adapter, so it will now look like that. Okay, so then want to make sure that everything is straight. So again, the same thing. The lower portion of my thermometer, which is the bulb, should be slightly lower than this curve in that distillation head. So basically I have here 3 pieces compared to the simple distillation. I have the RBF, fractionating column, distillation head. Okay, and then I'm gonna clamp it back in here. Okay, so I have it like that. All right, so I now have my setup longer than the previous one. Okay, and therefore I have to raise this part here. Okay, so my receiver is now going to be labeled as F1. Okay, the same thing as previous setup, except now that I have F1, meaning the first fractions, first 3 to 4 drops when we're doing fractional distillation, the beginning of the distillation, and then F2 is going to be at the last part of the distillation. So I'm going to clamp these in here. All right, so when you're clamping, you press these here and then you tighten it. Okay, then it's in place. So we're gonna start again with the heating. So again, the same thing. We are going to plug it into the transformer. The same thing, and I set it up to 120, and then we're gonna set it up again to 50. Okay, we might have to adjust it later, so we'll monitor the heating and the number of drops coming in the distillate. So right now, because we just started, I just assembled the setup, and it's just room temperature. It's 24 degrees C. So right now you can see that the solution is boiling, and I see a little bit of the distillate over here, and again that's the still wall, and this sand bath is connected to a transformer, and it's at 120 volt, and then I set it to 50. So now you can see that the solution is boiling, and so I have the steel wall inside. There's a fractionating column, and again I put a shield. It's aluminum foil. So right now the temperature is about 32, and I don't see any drops yet. I see a little bit of the distillate here, but it has not come up yet. You can see that there's like a drop actually at the bulb, the bottom of the bulb of the thermometer, and now the temperature went up. It's about 54, but I don't see any distillate yet. So the drop actually went back down, so it wasn't hot enough for it to distill. So as you can see, I added additional aluminum foil so that I can protect these. I kind of shield it to any air, to any draft, so that I can maintain the temperature when it's distilling. The first 2 drops I saw around 70 degrees, and I'm now collecting the drops in the F1 container over here. So I already took out the samples. I collected about 4 drops of the first fraction, so I labeled as F1, and then I already changed it to a new different container, which is just a flask, and I'm collecting the distillate in between, but I'm also reading every 2 or 3 drops of the distillate coming out while it's dripping into this container. So this is the first fraction that we're gonna be, first fraction F1 I labeled, so you can see that the sample at the bottom. So you can see that I'm collecting the distillate in here, and it's dripping slowly, maybe about 2 to 3 drops. So right now I've collected about almost a ml of the distillate, and you can see that the temperature is close to 80, so it's about 78. So it's pretty much constant right now, 78 degrees C. And you can see that I'm collecting more of the distillate here in the flask. So now the temperature went down from 78, was constant for a while, and then it went down to about almost 70 right now or so. Alright, so it went down, it's less than 70, okay? And then now, if you see the distillate that I collected, it's about 3 mils. So I added, the original solution was about 6 mils of a mixture of ethanol and 1 propanol. And I collected almost 3 mils of the distillate right now. So it now went down, remember, so I showed you the temperature went down, and I'm gonna increase the temperature a little bit, okay, by adjusting the transformer, the setting of the transformer to about 60 at the back. So right now it's 50, you see at the back it's around 50, and I'm gonna adjust it to about 60. And take note that I've been doing this, the distillation was slow because I want to make sure that I'm not overshooting the temperature. And it took a while for this to distill to about 3 mils of the volume, which is this one. So the volume, you see that I collected almost about 3 mils of that distillate. So the temperature actually went down again to less than 70, so it's now about 60, I think it's about 67 or so. So right now the temperature is now almost 90, and it went up, and you can see that I'm collecting more of the distillate here. So right now the temperature is about 93 or 94, about 94. Alright, so it went up, and then again I'm collecting more of the sample of the distillate. So right now I'm collecting the last few drops of the distillate for F2, and this is basically towards the end of the distillation. So I collected the F2 and like 2 drops at the end of the distillation. So basically that's the end of this part, which is part B, the fractional distillation. So this is I have F1, so this is the F2, and then I also have the F1 earlier, and those are the samples for the GC. This is the gas chromatography part of the experiment, and this is the instrument. It's called the gas chromatograph. GALMAC is the company, and so this is the instrument, and it's connected to a helium tank, and it's the pressure is about 30 psi, as you can see. So it's going through this metal tubing, okay, to the back of the instrument, And as you can see, there's that metal thing at the back. Okay, and then the gas is going through, and so if I connect this bubbler to this channel, you can see that the gas is gonna come out in here, and that's basically the outlet of the gas. So if you're pushing something in, obviously there should be an outlet, otherwise this thing will explode, right? Okay, so I'm gonna disconnect, and there's the column inside, as you can see, and I already have it set up. So there's the column setting, detector, injector, and then the current. So this is the injector port. So the mobile phase is helium, and we also have the stationary phase inside the column, and then we inject the sample over here, and then the sample will interact with the column, and there's a detector which is called thermal conductivity detector. So we are going to inject a sample, and then we'll see how it looks like. So this is the syringe that I'm going to use, and it actually accommodates 10 microliters, but I'm just going to inject less than 1 microliter. So first of all, I'm going to rinse out the syringe with the sample. So this is the sample that we're going to be using. It's 50% ethanol, 1 propanol, 1:1. And then I'm just going to rinse this out. And then I'm just going to use a paper towel. Okay, you see that the liquid came out. And I'm going to do that just twice. And then I'm going to withdraw about 5 microliters. And then inject about 0.5 microliter of the sample. So I'm gonna take out, because I pulled out 5 microliters, so less than 1 microliter. You can see the plunger. Okay, so I'm gonna inject over here, and then I'm gonna run. So inject, straight, push out, and then run. So nothing is coming out yet, it's just the baseline, it's just noise. And so the first peak came out, and remember in the sample we have 2 liquid components. The first one came out already at about it's about 40 seconds, and then went down to the baseline. So remember that the size of that peak would be proportional to the amount that we injected. So if you injected a lot, that peak would be big. And now the second peak came out. Remember, we have 2 components, so obviously we have 2 samples or 2 peaks that would come out, and then now it went down to the baseline. So the second peak came out at about 1.13 or 1.12 minutes, and I set it to the time for 2 minutes, so everything came out before 2 minutes. So this is the data. So first peak, that's going to be the most volatile, and then the second peak, the less volatile component in the mixture. So I now have 4 samples coming from the distillation, simple distillation, fractional distillation. And I use this sample ethanol to rinse out the syringe. And then this is our original sample that I already injected. So I showed you guys how to do that already. So now I'm ready to inject one of these. I'll show you again how to do that. And then again, I have the syringe. So this is the syringe, and it takes 10 microliters. Okay, so I will withdraw halfway. And so the same thing as I did before. And then I'm gonna use the paper towel. So I'm just gonna inject less than a microliter. So my guide actually is this, so that's 1. So that's 1 microliter, like below this steel casing. All right, that's 1 microliter. I'm gonna inject less than 1 microliter. So I'm gonna use this paper towel because I can see that the liquid is coming out. Okay, so the plunger is out here. Okay, so now I'm going to okay, so that's my sample. This is the injector port. I'm going to inject the sample, and basically the column is inside. I showed that already. So I'm going to inject the sample, go in, straight, out, and then I will run. So right now I'm running. This is basically just the baseline, and this is the sample, and I will give you guys each one a data to work on. So this is basically just the baseline. It's picking up some air that was in the syringe, but the intensity is very low, so it's not really, doesn't really mean a lot. And so when this peak comes up, all right, so the first peak is now, okay, came out the first peak. It's about 40.5 seconds. And then so depending on really the distillate, composition of distillate, then you will determine also, it's gonna come out in the peak area. So if there's only 1 peak, that's gonna be one component, and maybe there's another one coming out, so I can see that the peak is going up here. All right, so the first peak, large component, small peak, small amount. So the higher or the bigger is the peak, the more sample you have in that samples. Remember, we injected S1. Okay, so this is the run for S1. I have the first peak coming out, and then the second peak, small peak. So I set it to 2 minutes over here, and it's gonna stop at 2 minutes. So 2.2.00. So it will end. Okay, so I will replace this, and then I can run the other samples. So I'm gonna run S2. I will also, so after I run, so this is done, the S1, I'm gonna run now S2. And then after S2, I'm gonna run F1 sample. So I have to wait for it to come out. Otherwise, it's gonna be overlapping. And then the last one is gonna be F2. All right. So basically, that's it for this experiment. The last part is the gas chromatography portion of this experiment. So again, let me review. So the GC, I have everything set up, the column, the detector, the injector. So that's the setting. For the column is 120 degrees, detector is 131 or 130, and the injector port is about 130. And I also have the current set to to about 100. Okay, and then so if I open this part here, that's the GC. It's an oven. So that's the column. It's a coiled steel column. So the sample, when I injected the sample, you can see when I injected it, goes to the column, and it's gonna come out. It's gonna come out being pushed by the helium gas coming out in here. So again, the helium tank is over here. That's our mobile phase, and it's coming out here at the back and then going inside the column, going inside to the back. So you can see this part here going to the back, and then it's gonna push through the column, and then the gas that the sample that I injected will be vaporized. So basically this is the same as the distillation. It's gonna be vaporized because there's an oven, you're heating it up. And then it's gonna be separated by what is called, the detector is thermal conductivity. So there's a sensor that detects each of the components. That's why you see different peaks. So you have large peak, small peak. So it depends on the component, the quantity of each of the component in the sample. So that's the idea of the gas chromatography. It's a way to analyze the component of volatile liquid in the sample.